friction is the resistance to an object's motion through a fluid may be termed fluid friction. It may take the form of viscous resistance in a liquid or rather different character of air friction when an object moves through a gas. We can see an example of this when an object enters into Earth's atmosphere. When the object enters in contact with gases like nitrogen or oxygen present on it, the friction increases to the great velocity the object has. As the velocity is too much, friction cost is also too much, being directly proportional, causing the object to burn during its fall. The weight and the mass of the object is one of the factors that affects air friction. We can see this when, for example, we drop a coin and a feather. In this context, we can see how air resistance affects more the feather because it's lighter than the coin. But, on the other hand, if we put it in a vacuum where there is no air, we can see how both of them fall at the same time because there is no resistance. Another factor that affects air friction is the amount of surface in contact with the air. When there is less surface in contact with the air, the velocity increases because there is less surface being in contact with the resistance. We can see this when, for example, a parachutist falls with his head looking downwards. In this case, the surface in contact with the resistance is smaller, letting the velocity increase. On the other hand, when the parachutist opens the parachute, the surface is big, decreasing its velocity because there is more surface in contact with the resistance. Finally, the velocity of the object is one factor that affects air friction. We can see that these two variables are directly proportional. This means that with more velocity there will be more friction, and the same way but all the way around. When studying fluid friction, especially air friction, it's important to take into account the terminal velocity. Terminal velocity is when, for example, an object is falling, the force downwards is equal to the force upwards, then causing the net force equals 0. When this happens, the object reaches its terminal velocity. When this happens, the object can accelerate more during its fall, keeping its velocity constant. At very low speed, for small particles, air resistance is approximately proportional to velocity and can be expressed in the form for higher velocities on larger objects, the fractional drag is approximately proportional to the square velocity, where P is the air density, A the cross-sectional area, and C the numerical drag coefficient.